and you have the compression. But why AB, we ignore the Q. Okay, so a lot of times this is where a lot of times students get confused. Okay, I will try to explain a way to unconfuse you. Okay, and whenever I have a problem like this, right, I like to rotate it 180 degrees. Okay, I like to rotate it 180 degrees. So this is the same question, only rotate it 180 degrees. Okay, why I rotate 180 degrees? Why is that? Is because I like to do a Hangman analysis. Okay, what do I mean by a Hangman? Okay, so now when it's upside down, you can see it better. BC or AB, so this is point A, this is B, and this is C. AB will only see the load P because Q is applied before point B or above point B. It's not able to feel the load. Whereas BC is able to feel the load at P, tensile, and the minus Q. Okay. I know you'll say, Eugene, that did not really help. You just say things over again. I cannot visualize because that's how I feel. So what I will do is I will do a Hangman analysis. So this is a beam. Okay. And then this is my head. This is my head. This is my arms. This is my hand. And my hand is grabbing onto the pole. Then these are my hips. These are my knees. And these are my legs. Okay. Right. Okay. You see that now. Okay. Now, your hip if you are hanging, right, your hips can feel the weight of your what? Your weight of your
legs.
Your thigh or your legs, right? Your shoulder in a hangman configuration can feel the weight of your body plus what? Hip plus your what? Legs. Yes or no? Right? So if we put a load down here, okay, this is the P. Okay, this is the P. Okay. Question for you. Can the shoulder feel the P? It can feel it, yes or no? Right? If you're hanging,
Yes.
yeah, it can feel the P, right? The hip can also feel the what? The P. Yes or no? Now,
Yeah.
if I were to put a Q down here, I push you at that position, right? Okay. Can P or can this region, the feet, feel the Q? Where I circle in red, can the feet feel the Q? The answer is no. The feet is still the weight of your feet, yes or no? How about your knee? can your knee feel the Q?
No.
The answer is no. But can the shoulder feel the Q? The answer is yes. That's why at this configuration, if you are doing pull-up, okay, if someone push you from your butt or hold your hip, you are able to what? Lift up. Okay, you are able to lift up. So you can see that now in this figure, yes or no? That is why I like to put this upside down. Okay, likewise, if I have this structure over here, if I have this structure over here, okay, if I have this structure over here, what I usually tend to do is I love to paste it, and then what I'll do is I will rotate it clockwise. Hey, stupid diagram. I will rotate it clockwise. I will do it this way. Right? Once you rotate it this way, now you can see AB can feel the load of P1, P2, P3. BC can only feel what? P3 and P1. CD can only feel P3 and P1. DE can only feel P1. That's it. We are good to go. Am I right? Then you can visualize. This visualization is all, if you can imagine a hangman. Okay, this is the best way to analyze. Okay, or not, you are not sure. Why? When you are not sure, the problem is this. When you apply this formula over here, when you apply this formula over here, when you're not sure about P, is game over. Marcel, don't start the question. Marcel, go home. Okay? Okay? Okay. So now we have all the information. Okay? We have all the information that's needed. We have our loads now. Okay? So we are going to formulate. I'm going to, are you okay? Do you need time to copy? Yeah, okay. I did not hear any student telling me to stop. Okay, I'll do the next part of the question. So we are going to write out that the I'm going to copy the diagram. Okay, copying the diagram does help. I copy the upside down diagram. Okay, so we know that the total deflection is equal to the deflection of AB plus by deflection of BC. Okay. So deflection of AB, the load of AB only see 4 kilonewton. LAB, the length is 0.4. The cross-sectional area is 314.159 times 10 to the power minus 6. The Young's modulus is 70 times 10 to the power 9. Okay. And we know AB is going to be in tensile. Okay. Then we look at BC. We do a plus down here, and we know the P is going to induce tensile. The Q is going to induce compression. That is why we put a minus over there. Okay, it's going to induce a compression. Okay, so this is minus Q.
Sir, I have a question.
Yes.
Sir, is it 400 or just 4 kilonewton? Because you are putting 10 to the power 3 too.
Okay, 4 kilonewton. Sorry, you're right. Thank you for telling me. Okay.
No problem. Thank you.
Yeah, I don't know why I have 400 in my mind. Thank you. Or not everything will have gone wrong. 4 times 10 to the power 3 multiply by 0.5. The cross-sectional area that we have calculated is what was it? 2.827. times 10 to the power minus 3. And then this will be equal to 70 times 10 to the power 9. And then the whole thing will be equal to 0.
And sir, for the cross-sectional area for the BC, shouldn't be 2.827 multiplied by 10 to the power minus 6?
I thought it was minus 3. Did I forget the number? 2.827 times 10 to the power minus 3.
So I calculated it. So I got it 2827.43 times to the power minus 9.
Wait, let me, I can make a mistake. 2.827 times 10 to the power minus 3.
Minus 3?
Yeah. So 30 power minus 3 squared times by shift pi is equal to 2.827 times 10 to the power minus 3.
But you also have to multiply 10 to the power minus 3 by, like, it's going to be square, right? It's going to be 10 to the power minus 3 multiplied by 10 to the power minus 3.
I did not
That's
square.
Be...
I did square times shift pi is 2.827 times 10 to the minus 3.
Okay.
Right?
I don't know how I got this wrong.
Yeah, can you press this number and see what you get? Yeah, Taramprit is also getting the same thing.
Okay, I'm doing wrong something.
Okay. So, are you okay? Or you want me to?
Yes, sir. Yes, sir. It's good.
Or okay. If you're okay, I'm okay. So from here, we have why this thing is equal to 0, because at the end of the day, the total deflection has to be equal to 0. Okay, so this is equal to, so 0 is equal to, so we calculate 4 power 3 times 0.4 divided by 314.159 power minus 6 divided by 70 power 9 is equal to 72.757. So in all your calculation, I need it up to 3 decimal places except for the forces. Okay, forces I only need 1 decimal place. Okay, 757 times 10 to the power minus 6 plus by 0.5 divided 2.827 power minus 3 divided by 70 power 9. 0.5 divided by 2.827 power minus 3 divided by 70 power 9 times 4 power 3 is 10.107. Now is the time to learn the engineering units key, okay, ENG, okay. 107 times 10 to the power minus 6 minus by 2.527 times 10 to the power minus 9 Q. Okay. So with this Q will be equal to 72.757 power minus 6 plus 10.107 power minus 6 divided by 2.527 power minus 9. So the force will be 32.791. Okay, 32.791 times 10 to the power 3 Newton. Okay, and this is going up. Okay, so the next part of the question is determine the position of point B. Okay, so determine position of point B. So point B, in order to analyze point B, right? The top is the reference or the bottom, either one, okay? Okay. That is the reference. Reference means movement or y or motion is equal to 0. Right? Everything has to move relative from the fixed point. Okay, so to find the deflection of point B, all we need to do is to calculate deflection at DC. Okay, so deflection of BC, so PBC is 4 times 10 to the power 3 minus by